Everybody talks about Marie Curie like she just sat in a lab and got lucky with some glowing rocks. 2 Nobel Prizes, radioactivity, radium. Yeah, sure. But almost nobody talks about what she actually understood. The way she saw invisible rays and atoms and how everything connects. The way she turned that understanding into a fleet of vehicles that saved soldiers bleeding out on the Western Front. How she built the bridge between pure science and saving lives. How her brain worked differently than anyone else in 1895 when X-rays got discovered, and the world had no clue what they were looking at. This is not about metals. This is about a mind that cracked open the atom and then drove to the battlefield. Father taught physics and math. Mother ran a school. The family got crushed by czarist oppression trying to wipe out Polish culture. Jobs disappeared. Apartments shrank. 11 years old, Marie's mother died of tuberculosis. Oldest sister died of typhus. The girl who survived learned early that the world does not hand you anything. You take it or you die trying. No university for women in Russian-controlled Poland. She worked as a governess. Saved money. Sent her sister Bronisława to Paris first. Waited her turn. 1891 she followed. 24 years old. Sorbonne University. She earned degrees in physics in 1893. Mathematics in 1894. Highest honors both times. Slept in a freezing attic. Ate almost nothing. Studied until she fainted. She walked in looking for workspace. He saw her intensity. They married July 26, 1895 in Sceaux. No religious service. She wore dark blue instead of white. That dress became her lab coat for years. 2 months before the wedding, Wilhelm Röntgen in Germany discovered X-rays. Nobody knew what they were. Invisible light? Unknown force? The term itself meant unknown. X for the mystery. Henri Becquerel in Paris. Uranium salts fogged photographic plates in the dark. Radiation with no external energy source. No heat, no light input. Just uranium sitting there emitting rays. Becquerel announced it, moved on. Marie saw something else. She saw a question that would break physics. Pierre had built an electrometer sensitive enough to measure tiny electrical currents. Marie took uranium compounds, placed them in an ionization chamber, measured the current produced when radiation made air conduct electricity. First result. The activity depended only on how much uranium was present, not the compound structure, not molecular arrangement. The rays came from the atom itself. Marie's measurements said no. Something was happening inside the atom. Radiation was atomic property, not molecular chemistry. She tested thorium, same result. Radioactive. She invented that word. Radioactivity. The spontaneous emission of radiation from atomic decay. She named the phenomenon because she understood it first. A uranium ore. Mining waste. Her electrometer readings went wild. Pitchblende was 4 times more active than pure uranium. Chalcolite, another uranium mineral, twice as active. If activity came only from uranium content, this made no sense. Her hypothesis. A new element, far more radioactive than uranium, present in tiny quantities, hidden in the ore. They worked in a converted shed next to the School of Chemistry and Physics, former medical school dissecting room, poorly ventilated, not waterproof, roof leaked, no heat. They processed pitchblende by chemical separation, measured every fraction with the electrometer, traced the radiation. July 18th, 1898. First announcement to the Academy of Sciences. A new element in the bismuth fraction. 300 times more active than uranium. They named it polonium, after Marie's homeland. Poland, carved up by 3 empires for another 20 years. Spectroscopist Eugène Demarçay detected new spectral lines at 3,814.42 angstroms. Evidence of a new element. But chemists wanted isolation, pure samples, atomic weight, proof. They needed tons of ore. Edward Suess at University of Vienna interceded with the Austrian government. 100 kilograms sent to Paris, not enough. The Curies arranged for waste scraps from pitchblende mines, hundreds of kilograms. The Central Chemical Products Company helped with initial extraction in exchange for radium salts to sell later. The firm made a fortune. The Curies refused to patent. Science belonged to humanity. Marie did the final separations herself. Fractional crystallization, separating radium from barium, the 2 elements chemically similar. She worked in that freezing shed, stirring boiling solutions in massive cast iron basins. Physical labor, brutal. 4 years, 7 tons of pitchblende, 400 tons of water, 40 tons of corrosive chemicals, 1902, 1/10 of 1 gram of pure radium chloride, 1 decigram from 1 ton of ore. 1910, she isolated pure metallic radium. She never isolated polonium. Half-life 138 days. It decayed before she could purify it. Marie carried test tubes of radioactive material in her pockets, stored them in her desk drawer. Pierre taped radioactive barium to his arm to study burns. They published 32 papers between 1898 and 1902. One paper noted, that radium destroyed diseased tumor cells faster than healthy cells, the seed of radiation therapy. Recherches sur les substances radioactives, research on radioactive substances. First woman in France to earn a doctorate. The thesis shattered the indivisible atom. December 10th, 1903, Nobel Prize in Physics, shared with Pierre Curie and Henri Becquerel. The original nomination excluded Marie. 4 members of the French Academy of Sciences gave all credit to Pierre. Magnus Gosta-Mittag-Leffler, Swedish mathematician and advocate for women scientists, alerted Pierre. Pierre wrote back, demanded Marie be included. If it is true that one is seriously thinking about me for the prize, I very much wish to be considered together with Madame Curie. They won together, recognition of extraordinary services rendered by joint research on radiation phenomena. Pierre Curie stepped into the street during a rainstorm. A horse-drawn wagon crushed his skull. Dead instantly, 46 years old. Marie was left with 2 daughters, Irene, 7 years old, Eve, 18 months. The University of Paris offered her Pierre's professorship. First woman to teach at Sorbonne, she took the position, continued the research, measured radium's atomic weight, defined international standards for radioactive emissions. The unit eventually named Curie. 1911, Nobel Prize in Chemistry, solo recipient. Discovery of radium and polonium, isolation of radium, study of the element's nature and compounds. First person to win 2 Nobel Prizes. Still the only person to win in 2 different sciences. Construction finished, but researchers mobilized for war. August 1st, 1914, France declared war on Germany. German armies advancing toward Paris. Government moved capital to Bordeaux, 600 kilometers southwest. Marie took France's entire supply of radium, her own 1-gram sample, placed it in a lead-lined container, transported it by train to Bordeaux, locked it in a safe deposit box. Then she returned to Paris. The Radium Institute empty, the war raging, her mind already working on the next problem. Wounded soldiers lay in the field hospitals with shrapnel embedded, broken bones misaligned, bullets lodged deep. Surgeons operated blind. Infection rates catastrophic, death from treatable injuries. Marie saw the gap between technology and need. She understood X-rays at a fundamental level, understood radiation, ionization, how rays penetrate matter. She could build the bridge. If you value documented physics and wartime innovation history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. Also, this script is researched and factual. Using sources from IEE Spectrum published March 7, 2023, detailing Curie's mobile X-ray units, and the Smithsonian Magazine article from October 11, 2017, by Robert Emmett Hernan, documenting her battlefield work with exact casualty numbers and equipment specifications from her own book, Radiology in War, published 1919. Now back to the information. October 1914, first mobile X-ray unit ready. 2 months after war started. Marie had approached the Union of Women of France when French military delayed funding. Philanthropic organization gave her money for the first vehicle. She convinced wealthy Parisian women to donate automobiles, persuaded French manufacturers to donate X-ray equipment and portable electric generators, asked local body shops to outfit vehicles for free. The major obstacle, electrical power. X-ray machines needed electricity, no power lines at the front. Marie solved it, dynamo generator. The petroleum-powered car engine provided electricity to run the X-ray machine. She had lectured about them at Sorbonne, but never operated equipment. She learned. She also learned to drive, change flat tires, clean carburetors, repair truck engines, basic auto mechanics. Her expertise in chemistry and physics now included automotive maintenance. Marie in an alpaca coat with Red Cross armband. They arrived at field hospitals, unloaded equipment, hooked cable to lightweight generator, covered windows, unfolded table, installed ampoule, activated machine, set up in half an hour if no setbacks. Irene worked alone and unassisted when her mother was elsewhere. X-rayed wounded men, located fractures, bullets, shrapnel, young men who might have been her dance partners in peacetime. She trained personnel. When American officers arrived in 1918, she trained them too. Breakthrough came from French radiologist Charles Vaillant, process using treated paper to capture X-ray images instead of glass plates. Lighter, faster, more portable. Curriculum covered physics of electricity and X-rays, anatomy, photographic processing, equipment maintenance. They needed technicians who understood the science, not just operators following instructions. Marie taught them to think. Wounded arriving constantly, casualty clearing stations close to front lines. Marie and Irene X-raying men to guide surgeries, removing shrapnel, setting bones, preventing amputations, saving limbs that would have been lost to blind probing. Conservative estimate, 1 million wounded soldiers received X-rays during the war. Some sources say 1.2 million examinations total. 900,000 exams performed in final 2 years alone. Marie wrote in Radiology and War, published 1919, that the effort gave radiology a place corresponding to what it is capable of offering, not only in time of war, but also in time of peace. She had proven the concept. Mobile medical technology, bringing diagnosis to patients instead of patients to diagnosis. The portable X-ray unit underwent significant advances after the war. It remains standard in battlefield hospitals today. Later wrote book on X-ray safety drawn from war experiences. She attributed her own later illness to wartime X-ray work, not radium exposure. She had always protected herself from ingesting radium, but she operated X-ray equipment for 4 years with minimal shielding. She bought French war bonds instead with Nobel Prize money, all her strength at the service of adopted country, since she could do nothing for unfortunate native Poland. 1919, war over. Radium Institute finally ready for full operation. She dedicated herself to research, became director, led the laboratory, trained next generation. 1920, Curie Institute officially founded in Paris. 1921, she traveled to United States to tour and raise funds for radium research. President Warren Harding presented her with 1 gram of radium. 1932, Radium Institute opened in Warsaw with her sister Bronisława as director, now called Maria Skłodowska-Curie Memorial Cancer Center and Institute of Oncology. She recognized radiation originated within atoms, not from molecular arrangements. This was fundamental, atomic property, not chemical reaction. She proved atoms were not indivisible, not inert, not solid. Something happened inside them: decay, transmutation, energy release. Her work forced reconsideration of conservation of energy. Radium's radioactivity was so intense it could not be ignored. It contradicted established physics principles. Ernest Rutherford used radium samples from the Curies to probe atomic structure with alpha radiation. This led to the nuclear atomic model. Nucleus in center containing protons, electrons in space around it. Modern atomic theory started with Marie's insight that radiation came from within. Under her direction, world's first studies into treatment of neoplasms using radioactive isotopes began. Cancer therapy with radiation traces directly to her work. 1915, she produced hollow needles containing radium emanation, colorless radioactive gas given off by radium, later identified as radon, used for sterilizing infected tissue. She provided radium from her own 1 gram supply. Nobody did. Effects of ionizing radiation were unknown when she began. She carried radioactive materials in her pockets, remarked on faint light substances gave off in the dark, pretty, deadly, stored isotopes in desk drawer. No lead shielding, no dosimeters, no safety protocols, constant exposure for decades. Her notebooks from 1899 to 1902 remain radioactive today, stored in lead boxes. Will stay radioactive for 1,500 years, literal untouchable scientific legacy. X-ray work during the war, decades handling radioactive materials. Damage to bone marrow, cumulative effect. She knew it was coming. She had seen burns on other researchers, seen Becquerel's injuries. Pierre had burned himself deliberately to study effects. She kept working anyway. Science demanded it. Her remains and Pierre's moved to the Pantheon in Paris, French National Mausoleum. She was first woman interred there on her own merit. Recognition not just for science, but for changing what was possible. Breaking barriers placed in her way because she was a woman. Warsaw University refused her because of gender. Krakow University denied her position. The French Academy of Sciences tried to exclude her from Nobel Prize. She persisted. 2 degrees. 2 Nobel Prizes, 2 institutes, hundreds of papers, fundamental discoveries that launched nuclear science, made way for countless medical advances, impact in fight against cancer, 5 Nobel Prizes in the Curie family, Marie and Pierre 1903, Marie 1911, Irene and Frederick 1935, legacy of brilliance and persistence across generations. Her genius was understanding what the discovery meant, seeing that radiation came from inside the atom. Recognizing this meant atoms were not indivisible. Realizing this shattered foundational physics. Then taking that understanding and applying it, not just publishing papers, building equipment, training technicians, driving to battlefields, saving lives with the same invisible rays she had spent years studying in a freezing shed. She connected pure research to practical application better than almost anyone in history, from measuring tiny currents in an electrometer to designing mobile X-ray units, from isolating 1/10 gram of radium to training 180 women to operate radiological equipment, from coining the term radioactivity to establishing institutes that still lead cancer research, from understanding atomic decay to personally X-raying wounded soldiers at casualty clearing stations. The through line is the mind that saw connections others missed. Not as weapon, but as tool for saving. She saw that X-rays could guide surgeries at the front and built vehicles to make it happen. She saw that women could operate technical equipment and train them. She saw that radiation destroyed cancer cells and pioneered therapy. Every step required seeing what was possible before it existed. 1896. Becquerel discovers uranium radiation. 1898. Marie discovers polonium and radium. 1902. Isolates radium. 1903. First Nobel Prize. 1906. Pierre dies. 1911. Second Nobel Prize. 1914. War starts. October. 1914. First mobile X-ray unit operational. 2 months. From war declaration to functioning battlefield radiology system. 2 months. She had no experience operating X-ray equipment. She learned. She taught herself to drive. She recruited her teenage daughter. She convinced wealthy women to donate cars. She persuaded manufacturers to donate equipment. She trained women to be technicians. She established 200 permanent stations. She personally drove to the front, all while grieving her husband, all while raising 2 daughters, all while running a laboratory, all while advancing radioactivity research, while training next generation of scientists. The organizational ability matched the scientific brilliance. Every achievement required fighting barriers that did not exist for male colleagues. Every advancement came despite institutional resistance. And she did it anyway, kept working, kept discovering, kept teaching, kept saving lives. After Marie, it was field of study with medical applications, industrial uses, military significance. She transformed abstract phenomenon into practical tool. Before Marie, women in science were virtually non-existent at highest levels. After Marie, pathway existed. Difficult, yes. Barriers remained, but possible. She proved it. Her daughter proved it. Students she trained proved it. Marie Curie Hospital opened in North London in 1930. Staffed entirely by women, treated female cancer patients using radiology, research facilities, bombed in 1944, re-established as charity under Marie Curie name, became leading end-of-life charity in United Kingdom, still operating, supporting anyone with terminal illness, legacy extending nearly century after her death. Rutherford's atomic model came from studying her radium samples. Radiometric dating in geology and archaeology uses principles of radioactive decay she helped establish. Half-lives, transmutation, atomic instability, all traced back to her work. Medical applications of radiation, cancer therapy, diagnostic imaging, sterilization of equipment, all built on her discoveries and her insistence that science should serve humanity. She could have gotten rich. Radium was valuable. Medical applications, profitable. She and Pierre refused to patent. Central Chemical Products Company made fortune selling radium salts the Curies extracted. The Curies got nothing financially. They chose that. Science belonged to everyone. Helped establish need for safety protocols. Led to development of shielding requirements, exposure limits, monitoring equipment. Her sacrifice, unintentional but real, protected future researchers. They learned from her mistakes, developed lead-lined containers, remote handling tools, dosimeters, safety procedures. Nuclear industry safety standards trace partly to lessons learned from Marie Curie's illness and death. And her legacy lives in units of measurement, the Curie, defined as radioactive decay from 1 gram of radium, 3.7 times 10 to 10th power decays per second, named for Marie and Pierre, standard unit used for decades before being replaced by Becquerel in SI system. But Curie still used, still recognized, still honoring the woman who first measured radioactive intensity with precision. What made her understanding of X-rays genius was not just technical knowledge, it was synthesis. She understood invisible radiation as atomic property, understood how rays penetrate matter, understood ionization and electrical conductivity, understood chemical separation and fractional crystallization, understood physics of electricity generation, understood anatomy and where bullets lodge and how bones break, understood logistics of training programs and equipment distribution, understood organizational structures needed to support field operations, understood human psychology of wounded soldiers and overworked surgeons and bureaucrats blocking progress. She understood all of it, connected all of it, applied all of it. Chemist who became medical innovator, scientist who became humanitarian, researcher who became administrator, teacher who became field medic, all the same person, all the same driving vision, understand nature's secrets and use them to reduce human suffering. From pitchblende and freezing shed to X-ray machines at casualty clearing stations, from invisible rays fogging photographic plates to radiation therapy destroying tumors. From abstract scientific curiosity to practical life-saving application, the path required mind that could see across boundaries. Did not pursue medical uses. Ernest Rutherford probed atomic structure, brilliant physicist, Nobel Prize 1908, fundamental contributions, but stayed in laboratory. Pierre Curie himself, talented researcher, invented sensitive instruments, shared discoveries, but when he died, work continued. Marie was the one who isolated radium. Marie was the one who established institutes. Marie was the one who mobilized technology for war. The driving force was her mind, her vision, her relentless determination to push from discovery to application. When X-ray safety practices were inadequate during war, she documented problems and later wrote a comprehensive guide. She knew what she knew, admitted what she did not know, worked to fill gaps. This intellectual honesty strengthened everything she did. No bluffing, no shortcuts, just rigorous work and honest assessment. We must have perseverance and above all confidence in ourselves. We must believe that we are gifted for something and that this thing must be attained. Nothing in life is to be feared, it is only to be understood. I am one of those who think, like Nobel, that humanity will draw more good than evil from new discoveries. These were not empty platitudes. These were principles she lived. Perseverance through mother's death, sister's death, poverty, rejection, Pierre's death, war, illness. Confidence despite being denied education, excluded from positions, attacked for personal life. Understanding through decades of meticulous measurement and experimentation. Faith in human progress, despite seeing radiation's destructive potential. The thing that makes the X-ray work during World War I especially brilliant: she had just won second Nobel Prize in 1911. Sole recipient for chemistry, international fame. She could have stayed in laboratory, focused on research, pursued academic glory. Instead, when war came, she set it aside, put radium in vault, learned to drive, fixed engines, trained technicians, drove to front, risked her life, not from combat, but from exposure, from exhaustion, from accidents on bad roads and converted automobiles. Why? Because soldiers were dying from treatable wounds, because X-rays could help, because she understood the technology and could make it work, because science existed to serve humanity, not the other way around. Use it or waste it. She understood radioactivity at level no one else did. She understood X-rays as electromagnetic radiation, understood penetration and ionization and image formation. She understood what was needed at battlefield hospitals. She connected the pieces, built the system, made it work, saved lives. That is applied genius. That is understanding put to use. 100 years before a visitor to her Paris laboratory would have found it empty, her radium hidden 600 kilometers away, Marie herself at the front, age 50, operating X-ray equipment in casualty clearing station, daughter Irene working different front, both women using invisible rays discovered 22 years earlier. Ray's Marie had spent 2 decades studying and explaining and harnessing. The woman who broke open the atom now using electromagnetic radiation to save young men torn apart by machine guns and artillery. The connection is direct. The genius is complete. From fundamental discovery to practical salvation. From understanding nature to serving humanity. From invisible rays in a shed to X-rays on a battlefield. All the same mind, all the same drive, all the same relentless push to know and then to use what you know. July 1905, Pierre had written in despair about being unable to work, about constant interruptions from fame and public attention. Marie felt it too. Shattering of voluntary isolation was cause of real suffering. But when war came, and suffering was real and isolation was impossible and work was desperately needed, she set aside frustration. She worked, she built, she trained, she drove, she saved. That is the difference between brilliant researcher and genius who changes the world. Genius sees the need and meets it. 900,000 examinations in final 2 years of war. 1 million soldiers treated overall. Those numbers meant 900,000 times setting up equipment, activating X-ray machines, standing close enough to position patients and adjust angles and check images. 900,000 exposures. Cumulative dose over 4 years. Radiation damage to bone marrow. Price paid for understanding applied to saving. Price paid willingly. And here is what the numbers do not capture. Each of those 900,000 exams was a person. Soldier with bullet lodged near spine, soldier with shrapnel in chest cavity, soldier with compound fracture, soldier with infection spreading because foreign object remained embedded. Each X-ray meant surgeon could see, could extract, could repair, could save limb, could save life. Marie understood this, not abstract statistics. Individual humans, young men, somebody's son, somebody's husband, somebody's father, lying there bleeding and hoping and trusting these women with strange equipment to help them. And the women did help, because Marie taught them, trained them, gave them understanding, gave them tools, gave them confidence. 180 women operating X-ray equipment in 1914 through 1918. How many of them had operated any technical equipment before? How many had been told they could not, should not, were not capable? Marie showed them they could. They were. They did. Curie Institute in Paris still operates. Major Cancer Research Center. Curie Institute in Warsaw still operates. Leading oncology facility. Marie Curie Charity in United Kingdom still operates. End-of-life care for terminal patients. Mobile X-ray technology still used in battlefield hospitals. Radiation therapy still standard cancer treatment. Radioactivity safety protocols still protect researchers. All of it traces back. All of it started with woman in freezing shed, grinding pitch blenda and measuring tiny currents and asking why these ores were more radioactive than pure uranium. Asking and measuring and calculating and understanding and applying and teaching and building. The genius was in all of it. The understanding was what made it possible. Marie Curie, 47 years old, driving converted automobile on rough road toward battlefield. Red Cross armband on alpaca coat. X-ray equipment rattling in back. Generator ready. Darkroom materials packed. 17-year-old Irene beside her. Both women about to walk into casualty clearing station filled with wounded. Both about to set up equipment in 30 minutes. Both about to X-ray soldiers so surgeons can operate. Both using invisible electromagnetic radiation first identified 19 years earlier. Both applying understanding of atomic physics and ionization and penetration. Both doing work that will save hundreds of lives this day alone. Both exposed to radiation doses that will eventually kill them. Both doing it anyway because this is what understanding demands. This is what genius means. Seeing what is invisible, understanding what it is. Using it to help, no hesitation, no glory seeking, just work, just science. Just one woman who cracked the atom and then drove to the front to save the boys who were dying there. She worked so close to the materials that her very notes absorbed deadly radiation. The physical labor matched intellectual work, stirring boiling solutions for hours in freezing shed. The process could not be rushed. During war, systematic approach applied to X-ray training. Marie taught principles, not just button pushing. How X-rays are produced, tube voltage effects, exposure time, distance calculations, patient positioning, anatomy, photographic processing, equipment troubleshooting. Complete technical education in weeks. Women became expert operators. Many continued radiology careers after war. 200 permanent installations, equipment procurement, staff training, integration with surgical teams. Doctors learned to interpret X-ray images, identify fractures, locate shrapnel, judge depth. Marie trained medical staff alongside technicians. Wartime necessity meant accepting risks. She never minimized danger. Book became standard reference for radiation protection worldwide. Studied radiation effects, trained scientists who spread expertise globally. She pushed through, needed funds for research, needed to maintain international collaborations, needed to ensure radium research continued beyond her lifetime. The gram of radium from America went to Paris Curie Institute. She later arranged for second gram to go to Warsaw Radium Institute. Everything for the work, everything for advancing knowledge and helping humanity. Marie traveled to Poland for foundation ceremony despite declining health, saw her sister Bronisława take directorship, saw institution named for her in homeland, Kingdom of Poland when she was born, Russian Empire, then German occupation during World War I, finally independent Poland, 1918, carved from defeated empires. Marie had lived to see it, never lost Polish identity despite French citizenship. Polonium, named for Poland. Warsaw Radium Institute located there. Legacy planted in both countries, both nations claiming her, both rightfully so. She belonged to humanity but kept deep roots in place of birth and place of achievement. Could not produce enough red blood cells, slow suffocation at cellular level. She faced it with same clarity she brought to everything. Knew she was dying, knew why, kept working as long as possible. Correspondence continued. Advice to researchers, institute administration, even from sickbed. Finally, July 4th, 66 years, 7 months, 27 days, buried initially in Sceaux Cemetery next to Pierre. Simple grave. 1995, both moved to Pantheon, national recognition, but she would have cared more about the science continuing, the institutes operating, the students training, the cancer patients treated, the discoveries yet unmade. Half-life, 1600 years. Glows in dark from radiation. Both exist in tiny quantities requiring processing tons of ore. Both proven through spectral analysis. Both named by Marie. 1911. Quantum mechanics followed. All tracing to Marie's insight radiation came from within atom. Iodine-1, 31 for thyroid cancer. PET scans. Radiation treats half of cancer patients. Nuclear medicine scans millions yearly. Isotopes, sterilize equipment. All children of Marie's discoveries. Understanding energy resided in atomic nuclei. Einstein's equation, 1905. Marie lived to see relativity validated. Quantum mechanics developed atom split. Never saw bombs. Never saw full double-edged nature of her discoveries. She had faith humanity would draw more good than evil. History suggests mixed verdict. Just 2 scientists in shed. Pure research. After prizes, journalists everywhere. Demands on time. Scandal when affair with Paul Langevin became public, 1911. French press attacked. Right when she won second Nobel Prize, she went to Stockholm anyway, accepted prize, kept working. Nothing stopped her. Work was purpose, understanding was goal, application was duty. Her death accelerated radiation safety research. Scientists became more careful. Protection standards developed, maximum exposure limits, film badges, lead shielding. She became cautionary tale and inspiration. Proof radiation was dangerous. Proof benefits outweighed risks if properly controlled. Nobel Prizes, 1903 and 1911. First woman doctorate in France. First woman professor at Sorbonne. First woman interred in Pantheon on own merit. Mobile X-ray units designed. 200 fixed stations established. 180 women trained. 1 million soldiers treated. Radium institutes founded in Paris and Warsaw. Methods shared freely. Discoveries enabling technologies used daily century later. Life-given understanding radiation. Understanding applied, saving lives. Proved atoms were not indivisible. Won prizes, lost husband, kept working. Trained daughter as scientist. When war came, applied decade of radioactivity understanding to battlefield medicine. Saved hundreds of thousands, paid with her life. Left institutions still healing sick. Left knowledge still advancing. Left example still inspiring. That is genius. That is understanding. That is Marie Curie. From invisible rays in pitch blende to X-rays saving soldiers. From frozen shed in Paris to casualty stations at Marne. From measuring ionization currents to training women to fight death with electromagnetic radiation. All the same mind, all the same purpose. Understand and apply. Discover and use. Know and save. Nothing wasted. Nothing held back. Everything given to advance humanity, one measurement, one experiment, one X-ray, one life at a time. Her genius was not just in the discovery, it was in what she did with it.